How's it going, everybody? Good. And today we're just going to continue with what I was doing. And what I was doing was what was I doing? I was doing inlining the hard way. Okay. So I went ahead and just turned some of the more repetitive blocks of code into just their own methods, right? So we want to find mentions of each argument to this inline function. Then we want to find whether those mentions of these attributes are actually being modified. Okay, so the idea is that oh well, here we have it. Okay, so this is the test package that we're using. It's not code that's actually going to execute, just for demonstration. But the idea here is that we are inlining, therefore that means we will paste this code right into the line, therefore inlining it. And thus, if we call this function, say like such, then we can modify, then we could just modify y, right? So replace x for y and just modify that, and that will be fine. But suppose we call it with a constant. In that case, we cannot just replace every mention of x, replace it with 9. That wouldn't work. So what we have to do is just bite the bullet. If the arguments are actually being modified, then we actually need to first and foremost put this call into its own scope, okay? And we also need to declare a new variable for each one of these arguments, okay? So yeah, there's a couple things that go into that, okay? So the first thing, we need to first create the declarations, and then we need to do some renaming of the arguments. And let's just look what that's. Let's just take a look at what that is, okay? So the declaration is just going through the list of arguments and just adding a new node into the just adding a new node like at the beginning of the branch, okay? Because we want to ensure that the declaration is at the top, okay? It's the first thing that has to execute. Now here's a funny thing, right? So I made it so the declaration is simply equal to the name of the original variable, which would be in this case either x or xy. And so we would wind up with something like inlined function name and what will be x, okay? But the value would be x, and then what we can do is just replace every mention of x with the value that is passed. But that's actually not quite so smart, because yeah, we have to also replace all of these, right? And so yeah, it will get too confusing if we were to do that. So actually what I want to do here is have a counter and just say, declare this. So what I want to say is that the value of this should be actually it should be arg and y, okay? And what I'm gonna do is just say y, sorry, I. Yeah, yeah, I get confused with the letter names in English, okay? But anyhow, and so it will be argument such and such, and then what we can do is just look for this particular pattern and just replace it with something else. So in true automat fashion, we are going to utilize this format, okay? So this is the cut format, so to speak. And we are going to be doing the same with the return value itself, okay? Because in the case that we have to create a new scope in order to inline the function properly, so the example I gave yesterday was that suppose we do like this. That means that we have to replace this bit with this, like with the new scope, and paste the function in here, and then turn the return statement. So suppose we do a return x plus plus. What we have to do is say that b equals x plus plus, right? And I suppose that because we are modifying x, what we have to do is, make some declaration of x, some local declaration of x, assign it the value that we passed the function that was 2, and then just increment that, okay? So yeah, it sounds like this sounds like a lot of work, but trust me, it's cheaper than actually calling a subroutine. That's the crazy thing, right? So all of this stuff, but actually faster than calling a subroutine. Can you believe that? So basically, we are creating a call to something. Basically, we are creating a call to something. Yes. So yes, and we want to do this without jumps as well. So this is why we have to do it with its own scope, right? So, yeah. Not the best thing ever, but just something we're gonna have to deal with. Oh, and by the way, the album I'm listening to, that's Vampire Sorcery by Weeping Moon. Okay, so there you go. I'll put the link in the description, all of that. Okay. So anyhow, and so what I'm doing is just converting this return. I'm going to return it into a token, and that's going to be redval. And the reason why I just wrap things like this, right? So token and this thing, this syntax, it's because this is something I've never seen in any language whatsoever. I've never seen this kind of thing being done in any language. Very much like this tag kind of thing, right? So it's syntax that I pretty sure does not exist in any language, except, well, in Perl does use dollar and money and colon as a variable name, which it makes absolutely no sense, and they should remove that. But anyhow. But yeah, they're not gonna remove that because retro compatibility, and all that. People were crazy enough to use these kinds of variables, right? So this is a variable in Perl. This is a variable in Perl. This 2, 0 through 9, I'm pretty certain, are variables. $$ is also a variable. Like so many variables that are that just look like line noise, right? Okay, but anyhow, what we can do then is just find this and replace it. So what I'm gonna do is I'm gonna actually preach out this thing, and actually let me print out not well, let's print the tree itself, and then I'll print it out as a string, okay? That would be branch flatten, and keep root should be 0, it should default to 0. Okay, so oh, I have to update, sorry. There we go. Okay, so now you see we assign to our declaration the value of the first argument. So now we can pass in a constant, and it will work just fine. It will be converted, so to speak, into a variable, and then we can just assign to that variable, and and that will be valid syntax. Okay. So what we have to do now is actually have a case of inlining so that we can utilize this tree that I guess I'm actually going to convert it into a string, because now that we have the tokens here in place, we already know what we have to replace. And I've already made it so if we have any assignments, right? So this is symbolized by this hash here. So it would have the names of every variable that has been assigned to, of every variable, of every argument, of every function argument that has been assigned to. The name is within this hash. And thus, with keys, we have the name of every argument that has been assigned to. If any such arguments exist, then we just change the inlining strategy to create scope, right? If this flag is set, then we know we have to do things a certain way, okay? All right. And in the case where that isn't true, well, in that case, we're not really doing anything, so I should just comment this out. Because we're not really doing anything there, but anyhow. We'll handle that case. We'll handle other cases later on, okay? So, yeah. This case of just flattening the branch and removing the return would only be useful if the function in question is a one-liner. Only and only then. So actually, we should make it so we should make it so the line that what we're checking for here is actually another kind of flag, right? So we should be checking on whether the thing is a single line, right? And we would know that if we had a single branch within the tree, right? Because if all you have is the return statement, then I have to print this out without the flattening. So okay, let's do that. So here I have the branch. Okay, so it would be a branch reach out and just give me last. And okay, so you see the return is its own branch of the tree. And so if we only have return and possibly a semicolon, because it wouldn't be, it's not necessary to have it. If the tree matches that pattern, then we know it's a one-liner, basically. We know it's a one-liner, or even if it's just one branch and then a semicolon, then we know it's a one-liner. Anything else, we cannot be sure. Therefore, we would have to create its own scope for it for other reasons. Actually. But for one that is simply a one-liner, we can just paste the one-liner as it is generally. If it's not doing what it's doing here, where we are modifying the argument once again. So yeah, in this case, this should actually result it should be counted as an assignment operation. We're not doing that quite just yet, just because it's harder to check. For now, we are only checking for equals, but we'll be checking for other operators applied to the arguments later on. But for now, let's just focus on the minimal case, okay? Or at least the one that's easier to solve right now, and then we'll just solve all those as we go. Okay. So yeah, we would have to probably think of other flags and make other checks, but for now this is what we're doing. Okay. So let me just switch out the flattened version of the tree, and you see it's just a really big old statement. Okay, So what we can do is just put this in its own scope. And how do we do that? Easy. You wrap it. You wrap it in curlies, and now it's its own scope. Happy times. So, and yeah, I would totally just put that semicolon in there, even though it's not necessary. I just kind of like to do it. So anyhow. So now the thing is, we have to do the replacements in here. So just, I guess, just as a minimal demonstration, I can just do it with a straight up string, right? So I'm just going to write this string as if it were code, and what we will do is just find the dimension of the function itself, and then just replace it for the code, and try not to break everything. Okay, so it will be my b equals fn2. All right, we will have that. And then next line we are going to do something with b. Let's say we just want to return b, something like that. And once again, we're not actually going to run this code. This is just for demonstration. All right. So we have this this code as it is. And so what we would have to check is if our strategy is creating scope. What we would do is we would find dimension of this. Actually, would have to find this entire thing. So let's say code, and let's try to match. And generally, I would compile this thing first, but for now, just to be quick, I'm going to do it like this. And well, let's just do it like this, okay? And I think SM is what I want in here. Okay. And we do have to capture here. I would like to capture the arguments. Okay. All right. So, and oh, let me just show you something really cool. Okay, so we can do named capture here, which would be pretty nice actually. And yeah, you know what? It's better if I compile this. It's better if I compile this, because then I can just say fnre, yeah, just like that. We can now put this in here, and yes, you can use the X flag in here in the regex itself, and that would make it easier on you. But to be entirely honest, I like just doing this separately, and that's that. So okay. So actually, this should be any number of white space. Then this dot doesn't go there. Go here. Then here. This should consume any number of white space, but just to be absolutely sure, what we'll do is anything that is a space and anything that is not a space, which means any kind of character, right? So any kind of character until we meet again another parentheses. Okay. So yeah, I could say not this, but whatever. Actually, it should be not this, right? And so capture anything that isn't the terminating parentheses, but I'm not gonna. So anyhow, we capture all of that, and that's basically what we want to take out. So what we should do is replace that bit with this and a cut token, right? So we want a placeholder so that we can then go and replace the pasted token with the code. And so once again, I will use a token, right? So this kind of format, or I could just I could just use any format. I could do it like this. This one is kind of cute, so I'm gonna use it. I kind of like this kind of tag style, right? So I could do it like this, but that's, yeah. Anyhow, so if we match this, what you want to do is, well, first and foremost, we need to take a look at the arguments, right? So what we should do is say my args, and I think I already have this name in use, which might be true. Oh no, I don't. It's abstracted away. Great. Okay. But args itself is well, we can just overwrite it, no problem. Anyhow, so the processing that we want to do, and yeah, I know the indentation here is wrong, but I'm doing it this way just to let myself know, to let my brain know this is not this is just for testing, right? This is just for either testing or debugging, so it's not like a fixed section of the code. Okay. So if we match this whole thing and replace it with the semicolon and the semicolon and the token. Okay. All right. There's another problem. What if we have something like this? Ah, that's more complex. That is way more complex, actually. Huh. Well, this would mean we have to rethink some sections, because it would mean that we can't just do that and put the token there, or can we? Well, because this will become into a scope, right? And then we just do this like this, right? We can do that. We can do that. But let's just think about the most basic case first, okay? Let's get that working, all right? Okay. So args would have to be args, I guess. I think this is the right way to fetch the name capture. And if not, oh, actually I should do it. Deep length args. And else would just die. Actually, we should allow for no arguments in the case of the arguments being optional or having no arguments in the first place. But yeah, it's not what we're trying to test for right now. So, and okay, if we do have arguments, what we want to do is split them, and not just in any old fancy way. We want to do it like this. Okay, so took and took, oops, and args. Okay, and fucking hell. I'm just going to overwrite args. Okay, good. So, oops, that is that. Now I want to say that for my arg in args, and yes, I should be checking that the length of that the number of elements within this array is equal to the obligatory arguments of the function. I'm going to do that later on. Okay, this is just trying to get it done quick, just so I can, you know, just get something working. Anyhow. Okay. So all we have to do is, actually we need a counter here. Do I already have I? Nope. Okay. So we need a counter. What we should do is just first and foremost want to increase this, and we want to replace within the code no, actually not within the code, within the, let's call this fn, okay? So fn code, all right. Because we have the code itself, so this would be like the program, and fn code would effectively be the code that we're going to paste in here, okay? So within actually a copy of the code that we're going to inline, we have to replace these tokens, okay? So the return value and the argument. Okay, so let's do that. Arg I should be, and actually what I should do is put this in a QR, just because it's nice. And for some reason, sometimes you do have to escape the colons, sometimes you don't. I don't quite understand how this works. It's a little bit crazy, but anyhow. To my RE. And yeah, there would be no point in QRing this thing right now, because we're doing it in a loop, so it fits the purpose. But just nice. It's just nice, man. So yeah, let's just replace that thing with the value in args. Easy peasy. Okay. So we do that, and now whatever we pass to the function will be replaced in here, right? So the first argument we pass to the function will be take the place of this token. So you see how this works. You find the pattern, you replace it with a token, and then you just replace the token with something else once you have that data. So this is a placeholder, right? This is a placeholder, and you give it a very particular syntax which you know will not match against anything else. This is why I utilize a syntax that, at least in my experience, is not found in any other language. So that's just that. Anyhow, the last thing we have to do is replace the... We have to replace the return value for the name of the variable to which fn is being assigned. If we are calling fn without an equals, that means we are not assigning to anything, which would mean we are calling it in void context, which would mean we'd have to do returning superfluous, basically. I don't think it's superfluous is the word here. I'm sorry. It's useless, right? Like, it makes no point to return any value because we are just discarding it right away. Again, that case is still valid. It's not what we're going to handle now. So yeah. Okay, we're just going to handle this one case. And then we'll handle all the others, okay? So the idea would be that we would have to try and see if the match of fn, what it is preceded by. All right. For now, we're just assuming that it is always preceded by this, okay, by the equals, right? But this does mean that we have to take the variable that is being assigned to. So that means we need to match a sigil. And I'm just going to escape all of them, just to make absolutely sure. Because sometimes you can put money in here and it will work, and sometimes it doesn't. I don't quite know. No one knows at this point. Anyhow, I'm just going to call it red bar. Okay, red bar. And it has to be a valid name for Perl. So I can just do RV. Actually, I can just do it straight up. Lang Perl names. But what I would have to do is take this into a variable. So valid names, and just do it like this. You see how nice this is? You see how nice this is? Okay. So yeah, generally we would only have one sigil, but there are instances where you would have more than one, right? So in the case of the reference, you would actually the other way around. In the case of other reference, you would have more than one. So yeah. Okay. So we have the red bar. So let's just take that. Okay. So the length of this. Well, if we if we if we have a capture, a valid capture for return variable, that means we are not in void context, basically. If we are not in void context, then we have to replace the what did I call it? Red vol. Okay, so let's actually be consistent here, right? Let's actually try and be consistent with it. Why not? Okay. So we need the name of the return value, right? So it should be return variable, but what you gonna do? Anyhow, so red vol, and there it is. And so we just take this and now replace in the code red re. Why not? Red re. We change for the how is this thing go? Oh, the red ball, right? I'm sorry. Yeah, like it's so weird. This way of coding, but anyhow, like and this is like a new for me, right? So I'm not used to writing the code analysis and replacement myself using this level of sophistication, so to speak, right? So I'm used to doing text role substitution, but not substitution that's you know, like actually modifying the code both sides. So yeah, it's more confusing than what I'm used to, but not so bad, not so bad. So anyhow. Let's just print the effing code and see what happens. Okay, so we have a problem. 143 near my, and I forgot a semicolon. And 168. What happened here? What did I forget? Reval ret. Oh, okay. Okay, so it works. We replace the first variable with 2, and here's what we pass. We pass 2. Okay, so nice. And we change the return value, the red val here. We change it for the name of the variable that was created. So if we say something like some random string in here, it should replace for some random string in there. Okay, so nice. Now we can make this its own scope, and it should more or less work. Okay, let's try it. So we have a cut within code, and so in code we have to do s, and we have to match cut and change that for fn ball, right? Fn code. My fn code needs to go in this fn place. So code okay. So n and print that out, and here we go. Aha, but we have to declare the variable first. So, well, I should check that the variable is being declared first, right? Now, what we're gonna do is just say we're going to take this out and just say rebel and my. Okay, that didn't work. That didn't quite work. Okay. Oh, because I'm sorry. Okay. Red vol, and we need to do it this way. Okay. Oh, come on. There we go. Okay, I need to put the semicolon there. All right. So, yep, basically that's done. At least kind of, right? So the code used to be, actually, let's just print the, I'm sorry, actually let's print the original code and then the modified version, right? So then you can see it better. All right. So, oh, damn it. Yeah. Okay, so before the initial cut, okay? All right. So here's the original code. We take this entire thing and replace it with a cut, like you can see here, right? And then what we do is taking information from the code itself. That means the destination, right? So where the data obtained through this function, it has to be stored, if it has to be stored at all, and what the arguments are. And then using that data, we just modify the function code itself so that we can paste in place of the cut a new scope that will basically solve the function and assign the result to the whatever that result has to be stored, if it has to be stored at all. So now that we have this case solved, we can look into solving other cases of basically the exact same thing. So, are you confused yet? Are you confused yet? I guess what I would like to do first is I can, okay, so you can see we have two arguments actually. So one to do is we need to check for the number of arguments, and if we pass under args, so to speak, yeah, we would have to do something about that. Let's say x and pow. Like this is a very useful function, right? It's just for demonstration. Let's just say y. Okay. So if we do this, it's going to give us something kind of different, right? Because we are not replacing this y, because no reason is given to change it, because we are not assigning a variable a value to it, right? But wouldn't it just be easier to just assign a value, to just create a new variable for each one of these arguments and then just use those arguments? Kinda yes, kinda like yes, you know? Because else it's more checks that we need to run. Like, okay, so what are the arguments? Are they being assigned to? And you know, it checking that the argument is being assigned to it's its own thing, right? So yeah. But so why do all of that? Well, because if we do have a one-liner, and we are not, if we do have a one-liner, and we can make sure that we can just paste the code in without creating a new scope, if we can do that, then it makes sense to just replace the mentions of the argument with just the value that was provided. This does mean that we do need to have a token in place for each argument. So not just the arguments that were mentioned for assignment. Okay, so if we change the value of the argument, like we do here, then we need to declare a copy. Okay, but if we are not changing the value of the argument itself, if we're just using the value in an operation, then we can pass a constant and just replace the mention for the constant, and that will be fine. So actually, since we have the list of arguments in here, we can go about doing that. Yeah. So actually, let's do this. Okay. Let's run this for every branch. Okay, so it's going to go for every argument and change every mention for this. Okay, so will that give us the token? No, because at this it appears that at this point argument contains only those that those that are being assigned to. I think. Let's see. No, this should contain all of the arguments. All of them. Which means that at some point arguments is being changed. So let's actually preach that out. Let's put in a comma. Args. Do this. Okay. Oops. Actually, in a sec, it would be arg the value. There we go. Because it's nodes, and nodes have it's an object, so I can just print out the object. It's interesting because all we match is x, and actually x 3 times. That's a little bit interesting. It would mean that the function is actually it's actually doing something kind of weird. So it's finding every node. It's finding every branch of the tree where the variable is mentioned. So actually, if we preach out every branch, right, we do have the wider. So what we have to do is walk the branch and do replacing within the branch itself. Furthermore, we need to make it so the multiplication operator is recognized as such. All right. So now y appears, and that should mean that now it will be modified. Okay. It did modify it, but not in the way I was hoping it would. So, so let's see. Rename args is right. So it's doing this, and what I want actually is to change it for a token. So where is that happening? It's happening in the declarations. Oh, right. Okay. All right. All right. Okay. So it should be a different uh, procedure. Okay. No problem. So, yeah, I should just write a separate function for this because it's a similar operation, but it's different enough that I feel if I try to sort of chop it together, it's not. It's going to be more it's going to be more hard to understand. You know, I mean for me, not for you. So let's just say rebel arts, something like that. Just pass rd arts. I think we can do with just this. Here, this one would be an array of nodes, not names themselves. So I should say node. I could say branch, but node is good enough. So we need to node value. We need to change it for arg at I. Okay. Let's try that. Okay. Oh. Okay. Close that. And in here. Okay. So inline rep logs rd. Okay. And I think I don't need rd in here at all. Just not pass it. Haha! I need to update. All right. Yeah, not quite. Not quite. First and foremost, I need to advance I. Right. It's not gonna be so easy. Dang. Okay, so you got me. You got me. Right. So it's doing something else. Doing something else. Give me a sec. What's the thing look like that is? Okay, what? I'm gonna have to bridge it out at this stage. Okay. So it is creating this, which is not correct. Well, I mean, we could create we could just sanitize this array. Give me a sec though. Okay. Alright, so this one is just going through everything. Okay. And we can't have that. We actually need to filter this one out. Okay. Okay. Right, because it holds all of the arguments. Okay. Right. So we do need to filter that out. Okay, so my SSD args ISG. Actually, what I could do is just make it so. Wait, do I have RD open? No. So me, what I should do in here is assign branch to this. So then we can just say values within the assignment hash. Okay. Oh, I need to update. Okay. All right. Okay. So now, if I try to rename, it will still not work. It will still not work because yeah, I need to handle the count differently, right? So yeah. And one more thing. It exists, right? So if the value of the branch exists within the hash table, then we know we've already collected this, which means this is an argument that has to be replaced, which means we have to assign this. Problem is, so we would have to make it an array. It's slightly annoying, but we can do. So if we already have an array in here, all we have to do is just push. Okay? And this looks horrible. Let's just alias it so that we can just fit that within a single line, right? Okay. So now that that is an array, what we need to do is for every mention, actually, we need to We need to expand this. Just do that with a map. Let's see if it will let me do this. I'm not entirely sure. Apparently it did. Apparently it did, yeah. So okay. What we need to do then is we would have to create a hash for each one of these, okay? So the way I'm gonna do is I'm just gonna do it within the function itself, because that will be easier. So in REPL, the first thing we need to do is make a hash, alright? So I guess I can do for my node in args. So yeah, I need to iterate through the list twice, but I can't think of a better way. So basically node no I'm sorry, tab at node value plus hash if this does not exist. All right, so actually let's convert this into a key. Let's say that if not exists, tab at key, then tab at key equals just this, else just push tab at key, right? Just push the node. All right. And now we want to iter through in a sec. Okay, so we want to iter through every key within the keys of the table, and then for my node in, I'm going to say my nodes equals table at key array the reference. All right, so now we just iter through this, and we increase I at a later stage. All right, so that should work. Okay. But this one should be 1 and it's 0 because I need to declare this. Yeah, okay. And now it should work. Okay, all right. But for some reason, x is 1 and y is 0, which doesn't quite work. Huh. Right, so this one should be arg1 and this one should be arg0, which means that yeah, I made a mistake. We need the order of the keys, right? You cannot access a hash table in an ordered fashion. That's the problem. So yeah, let's just push keys. And I know whenever I do, there it didn't work. Okay, let me try again. I know my claps are loud, but yeah, I cannot help it. Okay. All right. Yeah, just being a little bit obnoxious in here with the separators, but yeah. Okay, I kind of want to do it, but just for this one, you know. All right. Like you wouldn't believe how much it helps me having these obnoxious little fuckers in the way. You wouldn't know how much it helps me anyhow. So what we have to do is, rather than iterate through the keys of table, we have to iterate through the order, right? And order is an ordered list of the keys, and so now it will be accessed in order. Now this does this have a problem? Let me think about it. Well, if the arguments are fetched in order, then this should work. But if the arguments are not, if they are fetched according to mention, then it wouldn't be alright. So let's see. Aha. Alright, so that's no good. That's no good. So now the order should be based on the original order. And that's what findargs is giving us. So did I close that file again? Holy. Okay. Oh, because I'm not returning the order. The order. All right. Hmm. Well, we should return the order, right? So let's do that. But I can't return two arrays. It's not going to work. So I have to do it like this. Okay. And in here, we'll just have to create two variables. So order and arguments. Okay. And we'll have to pass order to this. Right. Here in REPL, we need to take that. This, and now we do not need to put. Ah, fuck. Sure. 91, and there we go. I missed an R. Okay. 120 in inline. So I would assume this didn't quite work. Okay. All right. So, okay. Well, if it's not in, oh right, because we changed the value of this, and so now it's not available. Okay, that's fine. I could check if the key is in order, but that would take more time. So let's just check that nodes actually exist, that this actually exists. So next, if not exists, tab at key. Okay, and I have to take out the exit in here. Okay, good. All right, but that is not quite right. It's not quite right. Oh. There you go. Go to. Go to for everyone. Nice. Okay, and there we go. So now every mention of x is arg0, every mention of y is arg1. I hate my fucking life. But you see how goto can take me out of the vehicle? Like, it's such a traumatic thing, you know? All of these agile scrum sweatshop bullshit kind of modern day programmers, you know, they'll be like, oh, you use goto. Like, yeah, fuck yeah, I use goto. God bless goto, you know? It's a useful tool whenever you need, you know, any kind of flow control that's slightly more complex than, you know, for and while. Like, yeah, I could construct this with an if and increase the indentation level in order to make a Hadouken, or I could just make a jump. What's wrong with making a fucking jump within the same block? What's so wrong with that? You know, you guys never learn how the fuck to use goto. That's why you hate it so much, because you never found it useful, and because you never learned how to properly use it. And that's that. You know, there's nothing else to say. But you know, it's ridiculous that I constantly had to defend this position. God damn. Anyhow, now that we do have the replacements in place, we can pass a second argument, and that should give us the thing replaced, and so it is. Right? So now if I change this argument for, I don't know, some random string, now we will have this thing times some random string. Likewise, if I pass it in a, suppose I pass it, I don't know, or something. Yeah, right, so it's gonna put that, that name in place. So that's basically what we want, right? So in the case that we were modifying this variable that we're passing, well, in the case that it is a read-only, we should have to crash actually, but in the case that it was indeed a variable, and if we try to assign to it, then we would need to declare a copy. But because we are not redefining this variable, we can just use it, and that's fine. We don't need to do anything with that. And yeah, that's an inlining. Done the hard way. Done the hard way. So next up, because yeah, this is already a little bit too long, but so next up, there's a couple things we have to do. So first, we need to do the check for the argument count. So to do argc check, right? So check the argument count for the inlining, and the other thing that we should take a look at is whenever we have the following cases. Okay, so case 1 would be we have a while or if and something that's inline, right? So in this case, we have to do some extra work actually, because yeah, that that's not really going to work so well. Like, we would have to take this out in here, put a value, and right. So we would have to do all of this. Right, so take the function call outside of the if or while or else if, and do the whole scope thing in here, right? And yeah, that's slightly more complicated. Furthermore, we need to handle whenever we have something like this, right? So suppose 1 plus something, say, right? So in this case, we have to strip all of this, put the thing in here, assign, and then do this, right? So it's an additional step that we need to make. So yeah, this is far from over. This is far from over. But yeah, I will. What I'm going to do is just make it so I add one case at a time, right? So to not overwhelm myself with the amount of code that I need to write. So yeah, I think that's a wrap, and that's it from me. Have a good one.